Hello everyone and welcome to this video on the Python programming language and machine learning. So in this video, I'm going to create a program that can predict customer churn. And for those of you who don't know, customer churn occurs when subscribers or customers stop doing business with a company or service within a specific amount of time. And retaining customers is obviously important for companies because it boosts that company's revenue and helps the company to build a meaningful relationship with the customer. Now, what might not be so obvious is that customer retention is actually more valuable than customer acquisition. So, right now I'm on Google's website called colab.research.google.com because it makes it really easy to start programming in Python. All you have to do is go to this website and then log in using your Google account and get started writing your Python code. So let's go ahead and get started writing this Python program. So the first thing that you're going to want to do is click on File and then New Notebook, where a new tab will open up for you and then a new cell will open up. Now within this cell, in comments, I'm going to put a description about the program. So this is a Python program to predict customer churn. Next, I'm going to create a new cell. And in this cell, I'm going to import the libraries that I'm going to use throughout the program. So I'm going to import pandas as PD. I'm going to import numpy as np. I'm going to import sklearn. I'm going to import matplot lib.pyplot as blt. I'm going to import seaborn as sns. And then from sklearn.preprocessing, I am going to import label encoder. Also from sklearn.preprocessing, I'm going to import standard scalar. From sklearn.metrics, I'm going to import classification underscore report. And from sklearn.linear underscore model, I'm going to import logistic regression. And then from sklearn.model underscore selection, I'm going to import train underscore test underscore split. Okay, so let's go ahead and give this a run by clicking this button here to the left, and hopefully we have no errors, or hopefully I don't have any errors. Okay, so this cell ran with no errors. So let's create a new cell. And now in this cell, I'm going to load the data set. So I'm going to use Google's library to do this. From google.colab, I'm going to import files. Then I'm going to create a variable called uploaded and set it equal to files.upload. And let's run the cell and click on choose files. And here's the file that I want to upload that has my customer churn data. So I'm going to click open, and now it's loading up. All right, so that looks good. I'm going to create a new cell. And in this cell, I'm going to load the data into a data frame. So I'm going to create a variable called df, which will be short for data frame, and I'm going to set it equal to pd.read underscore csv. And within this parameter here, I'm going to input the file name. So I'm just going to come up here, highlight the file name, use Control C to copy it, and come down here and use Control V to paste it. And then I want to look at the data, specifically the first 7 rows of data. So I'm just going to type df.head and then input the number 7 and run this cell. Okay, and now I'm able to take a look at this data frame, and we can see that we get back 7 rows of data here, and we have all of our columns up top. So if we go all the way over to the right, we can see the target column, which is called churn, and then we can see the values in this column. They appear to be yes and no values. So no would mean that that customer did not churn, and of course yes would mean that the customer did churn, and each row is a customer. All right, so that looks good. Let's create a new cell, and I'm going to bring this up. So in this cell, I want to show all of the columns, or I want to show the number of columns and rows. All right, so just type df.shape and then run this cell. And now I can see that there's 7,043 rows or customers in this data set. And then there are 21 columns or data points on each customer. Okay, so I'm going to create a new cell. And in this cell, I'm going to show all of the columns. All right, so just type df.columns.values, and that should show all of the columns. Okay, and now we can see all of the column names here. And immediately I can see some interesting columns like customer ID, gender, let's see, phone service, internet service, contract, monthly pay or monthly charges, and obviously churn. And yeah, that looks about it. Oh, 10 years an interesting one as well. So yeah, definitely some interesting columns that I will want to look at. Okay, so let's create a new cell. And in this cell, I want to check for missing data or NA values. So in order to do this, just type df.isInA and then .sum and run this cell. Okay, and now we can see the column names on the left and the number of missing values for each column on the right. And right now, every single value is 0. So this tells me that this data has no missing values. All right, so I'm going to go ahead and create a new cell here. And now let's show some statistics. So I'll put that in comments here. Show some statistics. So just type df.describe and let's run this. And now we get some statistics on the data. So immediately we can see that the maximum tenure was 72 months. So that is about 6 years. And the minimum tenure was 0 months. And the mean tenure was 32.37 months. Now the maximum monthly charges was $118.75 for a customer, and the minimum charge or the minimum monthly charge was $18.25 for a customer, and the mean was $64.76 for the customers. All right, so I'm gonna create a new cell, and my first question is, well, how many people are churning and how many people are not churning or being retained or staying? So in order to get that count, I just have to do this df churn dot value underscore counts and then run this. And now this tells me that answer. And I like to comment my code. So let me put some comments here. Get customer churn count. Okay, so now I can see that 5,174 customers for this company did not churn, and 1,869 of those customers did. Okay, so now let's go ahead and get a visual of this. So we're going to visualize the count of customer churn. So in order to do this, just type sns.count plot and then df churn, and let's run the cell. And now we can visually see those same counts as bar charts here. So it makes it a little bit more obvious that there are more customers that stayed with the company than there are customers that left the company. Okay, so let's go ahead and create a new cell. And now I want to know what is the percentage of customers that are leaving. So I'm going to create a variable called retained. Actually, I'm going to create a variable called num underscore retained. And I'm going to set this equal to df, where df dot churn is no. And I'm going to get the number of rows for that. And then I'm going to create a variable called num underscore churned and set it equal to df, where df dot churn equals yes. And then I'm going to get the number of rows for that. And let's bring this up. Okay, now I'm going to print the percentage of customers that stayed. So just type print, and then it's going to be the num retained divided by the num retained plus the num churned. Okay. And I want it to be a percentage, so I'm going to multiply it times 100. And then I'm going to add some text. So I'm going to put a percentage sign there. So percentage of customers stayed with the company, and then a period. And now I'm just going to copy this using Control C, and I'm going to paste this here, and I'm going to change state to left, and this num retained will be num churned, and I will change this to left. All right, let's run this. Okay, now I can see that 73.46% of customers stayed with the company and about 26.536% of customers left the company. This is important because this tells me that if I were to take by random a customer from this data set, and if I had to make a guess, if that customer churned or didn't churn, usually you would have about a 50-50 chance, right? But based off of this data, it's very unbalanced. So I would have a better chance of making a guess that that customer stayed with the company for every customer that I randomly choose. And by the time I'm done, going through the whole data set, I would get 73.46% of those customers right. So the model that I build, I want it to be better than 73.46%. Okay, so I'm going to go ahead and create a new cell here. And now I want to visualize the churn count for both males and females. So here I'm going to visualize the churn count for both males and females. So just type sns.count plot, and then x will be equal to gender. My hue will be churn, and then data that I'm using will be the data frame df. All right, so let's run this. Okay, now immediately it doesn't seem to be much of a difference here. So it doesn't look like more males or more females left this company, or stayed with the company either. They seem about even based off of this chart. So maybe we don't want to take a look at the gender to figure out why these customers are leaving the company. I don't think gender has anything to do with it. All right, let's go ahead and create a new cell. And let's take a look at another column. So we're going to visualize the churn count for the internet service. All right, so just type sns.count plot, and then set x equal to the internet service column. The hue is still churn, and the data that we're going to be using is still df. So I'm going to run this. Okay, now we're getting back something useful. So immediately I can see that the highest number of customers that did not churn have DSL internet service. So we can see it by this bar here. And the highest count for customers that did churn have fiber optic internet service. So we can see that by this bar here. So immediately, if I was talking with this company about this data, I would show them this for sure and let them know that, hey, you know, the customers that are staying, they all have DSL. Most of them have DSL, and the customers that are churning mostly have fiber optic internet service. Okay. All right, so let's go ahead and create a new cell, and let's take a look at some other columns. So I'm going to create a variable called numerical underscore features, and I'm going to set it equal to tenure and monthly charges. So these are going to be the two columns that I'm looking at because I thought that they were pretty interesting from the very beginning. And this time I'm going to create a histogram for this data instead of the bar charts. So I'm going to create a variable fig and then comma x. And I'm going to set this equal to plt.subplot. And I want one row with 2 columns, and then I need to give it a figure size. So the fig size will be equal to 28, 28 by 8. All right, so that looks good. Now let's get the data. So I want all of the data from the data frame where the churn is no. And I want this for our numerical features. So that's both the tenure and monthly charges columns. And I want this to be a histogram. So .hist, and then our histogram will have 20 bins. And I will set this color equal to blue. And I want it to be slightly transparent. So the alpha will be equal to 0.5. And let's see here. The axis will be X. All right, so that looks really good. I'm going to take this here and I'm going to copy it and paste it. And I'm going to change just a few values here. So now I want the churn to be yes. I keep the bins. I want this to be a histogram. I'm going to change the color for churning being yes to orange, just to match this graph up here since it's blue and orange. And let's go ahead and run this cell. All right, so it looks like I've messed up. Let's see, it's plt.subplots. Let's run this. Okay, so now I can see these two plots. On my left is the monthly charges histogram, and on the right is the tenure histogram. And immediately I can see that the customers, most of the customers that are staying have a monthly charge somewhere between 20, maybe a little less than 20, but I'd say 20 and about $30. And that's very obvious by that this big amount here on this histogram. And what we can also see is that the churn count is a lot higher, somewhere between, I guess I say, looks like 70 here and about $100 for the monthly charges. So that seems fairly obvious as well. All right, and then if we look at tenure, we can see that most of the customers that churn somewhere between 0 and about 10 months, right? And for the customers that did not churn, they seem to basically have a higher tenure. So it seems to be somewhere between, I guess, I just say 65 and 72 months. All right. So the ones who left have a lower tenure, and the ones who stayed have a higher tenure. Okay. So let's go ahead and create a new cell, and let's do some data pre-processing. So I want to remove unnecessary columns or column. So immediately I saw that customer ID column, and customer ID will be useless for the model. So let's go ahead and get rid of it. So I'm going to create a variable called clean underscore df and set it equal to df.drop. And I'm going to drop the customer ID column, and that's going to be on axis equal to 1. All right, so there we go. That looks good. And let's run this. Okay. So now I want to take a look at the number of rows and columns in my data set. So look at the number of rows and columns in the data set. So just type cleaned underscore df dot shape, and let's run this. Oh, I made it. It's called clean and not cleaned. I call it cleaned. Let's call it cleaned. And let's run this again. Let's run this. All right. So now I can see that there are 7,043 rows of data still, but now there's only 20 columns, where before it was 21 columns. Okay, so we successfully dropped one of the columns, being customer ID. Okay, so now I want to convert all of the non-numeric columns to numeric. So for column, and cleaned underscore df dot columns, if the cleaned df at that specific column, if that data type is a number, then I'm going to continue. All right. If it's not, then that specific column for our data frame, cleaned df, will change to a number. And in order to do that, we just have to type label encoder dot fit underscore transform, and we're going to transform cleaned underscore df at that specific column. Okay, so here we're transforming that value to a number, and then we are placing that value back into our data set for that specific column. So let's go ahead and run this. All right, that looks good. I'm going to create a new cell, and now let's take a look at the new data set and data types. So just type cleaned underscore df dot d types, and there we go. So now we can see that all the data types for our data set are numbers. And again, I'm going to put a comment here because I like to comment my code. So show the new data set data types. All right, let's create a new cell. And in this cell, I want to show the first 5 rows of the new data set. So here we'll show the first 5 rows of the new data set. So just type cleaned.df.head, and let's run this. Okay, and now we can see a sample of the data, and we can see that they are all indeed numbers as expected. All right. Okay, so next I'm going to scale the data. So I'm going to create the feature data set, which will be called X, and it will contain all of the columns from clean DF except for the churn column, which is our target. So we're going to just get rid of it here. Let me bring this down a little bit. There we go. So access is going to equal 1. And again, this is the feature data set. And now I'm going to create the target data set, which I'm going to call Y, and set it equal to clean DF, and it's going to contain all of the data from the churn column. All right. And now I have those two data sets. So let me go ahead and scale the feature data set. So I'm going to set X equal to standard scalar dot fit underscore transform. And that should do it. So let's run this. Okay. So let's create a new cell. In this cell, I'm going to split the data. Let me go back up. In this cell, I'm going to split the data into 80% training and 20% testing. So I'm going to create my variables x underscore train, x underscore test, y underscore train, y underscore test, and set them equal to train underscore test underscore split. And we're going to input, let me bring this down again. We're going to input our feature data set and the target data set, and then give it a test size. And the test size will be 0.2. And give it a random state. Don't worry about what random state is for now. You can set it equal to any value, but make sure you keep the same values for whenever you're doing testing and things like that. But for now, don't worry about it. Just make sure you have the same numbers, and the random state can be any number. Just make sure you keep it the same. Okay, so that looks good. Let's run this. All right, let's create a new cell. And in this cell, I'm going to create the model. So I'm going to create a variable called model and set it equal to logistic regression. And next I'm going to train the model. So just type model.fit and input xtrain and ytrain. And let's run this. All right, that looks good. I'm going to create a new cell. And finally, we can make some predictions. So I'm going to create a variable called predictions and set it equal to model.predict, and we're going to predict the values from our x-test data. So here I'm just create the predictions on the test data. All right. Now let's print the predictions. So I'm just going to type print predictions and let's run this. Okay. And obviously I can't see all of them, all of the data from printing it, but if you wanted to, you can go one by one and look at each prediction for the test data, and you can compare it with the target test data. All right, so that looks good. Let's go ahead and create a new cell, and here I'm going to check the precision, I'm going to check the recall, and I'm going to check the F1 score for our model. So just print classification underscore report, and we're going to input y underscore test and predictions, and let's run this and see how well the model did. Okay, so now we can see that our model has about a 91% recall, which is really good. It has 85% precision, which is okay, and it has an F1 score of 88%, which is pretty good. The maximum F1 score can be is 1 or 100%. And let's see, it has an accuracy of about 82%, which is better than the, what was it, 73, oh yeah, 73.46% from just guessing. So this model is it'll be useful to me. It's better than me guessing, at least. And so that's basically it. I hope you all really enjoyed this video. Please leave any questions you have in the comment section. Don't forget to hit that subscribe button and that like button. And I have many other videos on machine learning and on Python, so be sure to check those out. Also, I have articles on my programs that I create on this YouTube channel, so you can check those out. I'll put a link to the article for this program in the description below. And as always, thank you all for watching, and I'll see you all in the next video.